Good morning, everyone. I am Jayalakshmi from Tech Multitech, Dr. Rangarajan, Dr. Shakuntala Engineering College of the Department Artificial Intelligence and Data Science. Now I'm here to present a video lecture on the topic Deep Learning under the course Artificial Neural Network and Deep Learning. Deep learning is nothing but the subset of machine learning that utilizes artificial neural network with multiple layers to analyze data to learn complex patterns. So these networks, inspired by the structure of the human brain, are designed to automatically extract features, natural language processing, and more. Deep learning relies on ANN, that is artificial neural network, which consists of the interconnected nodes that is called as neurons organized in layers. When it comes to layers, we have three different layers, that is input layer, hidden layer, and output layer. So deep learning networks have multiple hidden layers, allowing them to learn historical representations of the data. So deep learning models can learn from large amount of unlabeled data, automatically identifying patterns and features. So unlike traditional machine learning, deep learning models can automatically extract the relevant features from the data, reducing the need for manual feature engineering. Deep learning in AI is a method that teaches computer to process data in a way inspired by the human brain. So deep learning models can recognize the complex pictures, text, sounds, and other data patterns to produce accurate insights and predictions. Artificial intelligence AI is a set of technologies that enable computers to perform a variety of advanced functions, including the ability to see, understand, and translate spoken and written language, analyze data, make recommendations. AI refers to the ability of the computer system to perform tasks that typically require human intelligence, such as learning, problem solving, and decision making. So it emphasizes a range of technologies to enable machines in mimic human cognitive functions, including perception, language understanding, and creative problem solving. So it aims to create systems that can perform tasks that human can do, or even surpass human capabilities in certain areas. So the key aspect of artificial intelligence is its ability to learn from data and experience, adapt to new situations, and solve complex problems. So AI systems can analyze information, identify patterns, and make decisions based on that analysis. So it is not limited to a single task. It can be applied to a wide range of applications from image recognition to natural language processing. So it is an umbrella term for various technologies, including machine learning, deep learning, and natural language processing. So it is a subfield of computer science focused on development intelligent agents, which are systems that can reason, learn, and act automatically. So continuous development is nothing but a constantly evaluating field with ongoing research and development to improve the capabilities and expand its applications. Here are some of the applications of artificial intelligence. In this slide, we will discuss about machine learning. So it is a field of computer science that enables the systems to learn from data without being explicitly programmed. So it is a subset of AI focused on developing algorithms that allows computers to identify patterns, make predictions, and improve their performance over time with experience. So essentially, ML allows machine to learn from data and make decisions or perform tasks with minimal human interventions. So ML algorithms analyze large data sets and relationship, which they then use to make predictions or decisions on new or unseen data. So unlike traditional programming where computers follow a set of predefined instructions, so ML algorithms learn from the data that are given and adapt their behavior accordingly. So we have some types of ML, which includes supervised learning, unsupervised learning, and reinforcement learning. And the applications of ML is to used in a wide range of applications, so including image recognition, natural language processing, recommendation system, fraud detection, and more. In this slide, we will discuss about why we need machine learning. So machine learning is essential because it enables systems to learn from data and over the time without explicit programming. So this capability is crucial in today's data and rich environment where vast amount of informations are generated constantly. So machine learning helps analyze this data to identify patterns, make predictions, and automate tasks, leading to increased efficiency, reduced cost, and improved decision making in various fields. So here we have some handling massive and complex data where the volume and variety of data generated today are unprecedented. So machine learning algorithms can process and analyze these massive data set to extract valuable insights that humans might miss. So machine learning can automate repetitive tasks, also freeing up the human resources for more complex and creative work. So examples include automatic customer service through chatbots, so streamlining manufacturing processes and optimizing logistics. So making predictions and informed decisions. So models can predict future trends and outcomes based on historical data. So this predictive capability is valuable in various applications such as predicting equipment failures, so forecasting demand, and assessing financial risk. So personalization and recommendation. Here we have our machine learning algorithm can personalize user experiences by recommending products, content, or services based on the individual preferences. This is widely used by e-commerce platforms, streaming services, and social media companies. Here we have some machine learning algorithm advantages. So it offers the numerous advantages, primarily focusing on the automating tasks, improving decision making, and enabling data-driven insights across various fields. Machine learning excels at handling large data sets, identifying patterns that humans might miss, and continuously improving its performance over time. So this leads to increased efficiency, accuracy, and scalability in various applications. So this ML algorithms can automate tasks like data entry, processing, and analysis, freeing up human resources for more complex and strategic work. So by automatic processes, machine learning can significantly improve efficiency and speeds in various tasks such as process, customers' feedback, or managing inventory. And automation minimizes the impact of human error, leading to more consistent and reliable resources, especially in tasks requiring high accuracy. So, data driven insights and decision making can analyze vast amounts of data, uncovering patterns and insights that could be impossible for humans to identify manually. So, by providing the data driven insights, machine learning helps organizations make more informed and effective decisions across various domains. Some other advantages of machine learning are scalability, cost efficiency, and innovative enablement. Now we will discuss about some of the disadvantages of machine learning. So these models are highly reliant and availability quality and reliance of data. So insufficient, biased, and inaccurate data can lead to flawed predictions and decisions. Data preparations, including cleaning, pre-processing, and labeling, is also a time-consuming, resource-intensive process. So high computational work. So this is one of the disadvantages in ML is that the cost high. Training and deploying machine learning models, especially complex deep learning algorithms, require sustainable computational resources and specialized hardware like GPU. So these resources are expensive to acquire and maintain, potentially possessing a barrier for smaller organizations. So the advanced ML models can particularly be deep learning networks operate as black boxes, meaning their internal decision making process are not easily understandable or transparent. Here we will discuss about the deep learning process. That DL process includes understanding the problem, whether the deep learning is good to fit, and identifies the relevant data sets and prepare them for analysis. So next is chooses the type of deep learning algorithm to use. So next is trains the algorithm on large amount of labeled data. So finally, test the model's performance against the unlabeled data. In this slide, we will be discussing about the layers in neural networks. So it consists of layers of interconnected nodes or neurons that collaborate to process input data. In a fully connected deep learning network, data flows through multiple layers where each neuron performs nonlinear transformation, allowing the model to learn, integrate representations of the data. In a deep learning neural network, the input layer receives the data, which passes through the hidden layers and transform the data using nonlinear functions. The final output layer generates the model prediction. In this slide, we will discuss about how machine learning works. So it can work on a smaller amount of data set by applying the statistical algorithms to learn the hidden patterns and relationship in the data set. So it can work on the CPU or requires less computing power as compared to the deep learning. Deep learning is a subset of machine learning that uses multi-layer neural networks called deep neural networks to simulate the complex decision-making power of the human brain. Some form of deep learning powers most of the artificial intelligence applications in our lives today. In this slide, we will discuss about the applications of deep learning. So applications of deep learning includes the data science, NLPs, computer vision, neural networks, healthcare, cybersecurity, social media, and autonomous vehicles. The machine learning uses the algorithm and learns on its own, but may need human intervention and correct the errors. Whereas in deep learning, it uses the advanced computing, its own neural network to adapt with little to no human intervention. Next, the components of DL. The models are complex, layered neural network designed to analyze data and learn integrate patterns. So key components include different networks, architectures like convolutional neural network, recurrent neural network, regenerative adversarial neural network. These models involve data understanding and pre-processing. So DL model building, training, validation, and interpretation. So DL also encompasses various learning paradigms like supervised, unsupervised, and reinforcement learning. Deep learning models are data hungry. The quality and quantity of data significantly impact the model's performance. So these are the mathematical functions and rules that guide the learning process. So examples include neural networks, convolutional neural networks, and recurrent neural networks. So deep learning requires significant computational power, often provides by GPU to train large models efficiently. So deep learning requires skilled individuals to design, train, and deploy models. This includes data scientists, machine learning engineering, and domain experts. The evaluation of the neural architecture. So this limitations lead to the development of multi-layer perceptrons. It introduced hidden layers and nonlinear activation functions. So MLP trained using a backpropagation could model complex nonlinear relationship marking a significant leap in neural networks capabilities. So, this evolution from perceptrons to MLP laid the groundwork for advanced architectures like CNN and RNN, showcasing the power of layered structures in solving real world problems. Types of neural network. In neural network, we have a feed-forward neural network, convolutional neural network, recurrent neural network, generative adversarial neural network, autoencoders, transformer networks. In this slide, we will discuss about deep learning applications. So DL has a wide array of applications across various industries. Common uses include natural language processing, computer vision, fraud detection, autonomous vehicles, healthcare, recommendation systems, and speech recognition. So in natural language processing, we have the machine learning translations where the deep learning models like Google Translate leverage neural networks to translate languages with increasing accuracy. The text generation, where the deep learning powers tools that generate human quality text, including chatbots, content creation, and code generation. So next is the sentiment analysis. So in this, deep learning algorithms analyze the text to determine the emotional tone or option the opinion expressed, which is useful for understanding the customer feedback and social media trends. So next is the speech recognition. So in this, the DL, that is your deep learning models, like those used in Siri and Alexa, convert the spoken words into text, enabling voice controller and virtual assistants. In this slide, we will discuss about natural language processing. So the NLP stands for natural language processing, and it is a field of artificial intelligence that focuses on enabling computers to understand, interpret, and generate human language. So it allows machines to process both written text and spoken words. So bridging the communication gap between humans and computers. So NLP is used in a wide range of applications from virtual assistants to search engines and language translation tools. So understanding the language for the NLP enables computers to analyze the structure and meaning of human language, including grammar, syntax, and semantics. So the natural language processing allows computers to generate human-like text and speech, enabling them to respond to user input or create content. The NLP helps computers understand the intent, sentiment, and contents behind the language, allowing for more accurate responses. In this slide, we will discuss about the reinforcement learning. So reinforcement learning is a machine learning algorithm where an agent learns to make decisions in an environment to maximize the cumulative reward. It's a trial and error learning process where the agent interacts with the environment, takes actions, and receives the feedback in the form of the rewards, which guide the agent towards the optimal behavior. ChatGPT is a generative artificial intelligence chatbot developed by OpenAI and released on November 30, 2022. So it uses GPT-5, a generative pre-trained transformer, to generate text, speech, and images in response to user prompts. In this slide, we will discuss about deep learning models. So here we have some six different deep learning models. First one is autoencoder, second one is sparse autoencoder, third one is variational autoencoder, fourth one is long short-term memory, fifth one is convolutional neural network, and the final one is deep belief network. In this slide, we will discuss about autoencoders. Autoencoders are a type of ANN primarily used in unsupervised machine learning for learning efficient data representation. So they work by compressing the input data into a lower dimensional representation and then reconstructing it from this compressed form. So the goal is to minimize the reconstruction error, forcing the network to capture the most important features of the input data. So in structure, we have the autoencoders consists of two main parts. One is the encoder and the next one is the decoder. The encoder compresses the input data into a lower dimensional representation called the latent space or code. The decoder takes this compressed representation and reconstructs the original input data. So in training, we have autoencoders or trained using unsupervised learning, meaning they learn from unlabeled data. The network learns to minimize the difference between the input and reconstructed output, essentially learning to compress and then decompress the data. So the purpose of the autoencoders are used to various tasks, including dimensionality reduction. So the reduction the number of features in a data set while retaining the important information. Some of the advantages are learns nonlinear feature representation, useful when labeled data is scarce. So can handle the complex high dimensional data. In the slide, we will discuss about the limitations. If the bottleneck is too wide, they can just learn, identify the mapping, requires the careful tuning, not always interpretable. Reconstruction may not generalize well outside the training distribution. The sparse autoencoder is a type of autoencoder that is trained to reconstruct its input while also being constrained to use only a limited number of hidden units at any given time. This sparsity constraints encourages the network to learn more efficient and interpretable representations of the data by forcing it to the focus on the most salient features. The variational autoencoders are a type of deep learning model used for the unsupervised learning and data generation. They extend traditional autoencoders by incorporating probabilistic techniques, allowing them to generate new data that resembles a training data set. So the VAE, that is your variational autoencoders, encode input data into the latent space as probability distributions, that is mean and variance, rather than fixed points, and then decode it back into the original form or a variation of it. The long short-term memory autoencoder is a neural network architecture that combines the capabilities of LSTM, that is long short-term memory, networks and autoencoders for processing sequential data. It uses LSTM for encoding and decoding, make it particularly effective for tasks including the involving time series data and anomaly detection. The CNN stands for the convolutional neural networks. It is also known as ConNet. It is a specialized type of deep learning algorithm mainly designed for tasks that necessitate the objective recognition, including image classification, detection, and the segmentation. So CNN are employed in a variety of practical scenarios such as autonomous vehicle, security camera systems, and others. In this slide, we will be discussing about the DBN. The DBN stands for Deep Belief Network. It is a probabilistic generative model and a type of deep neural network composed of the multiple layers of hidden variables. It's known for the ability to learn complex patterns and representations from data, especially in unsupervised learning tasks. So the key characteristics of DBN can generate new data similar to the data they were trained on. They consist of the multiple layers of interconnected nodes, allowing them to learn hierarchical representations of data. The core building blocks of DBN or RBM, which are trained layer by layer in an unsupervised manner. The DBN can be used for both unsupervised learning tasks and it works using the typically pre-trained layer by layer using the RBM. So each RBM learns the representation of the data from the layer below. So after pre-training, the entire network can be fine-tuned using a supervised learning algorithm like back propagation to further optimize the performance on a specific task. So each RBM in a DBM is trained independently using the context of divergence and approximation method for calculating the gradient of a log likelihood of the data. In this slide, we'll be discussing about the advantages of the deep learning. It is one of the biggest advantage of using deep learning approach is its ability to execute feature engineering by itself. So in this approach, an algorithm scans the data to identify features which correlate and then combine them to promote faster learning without being told to do so explicitly. The disadvantages of deep learning or high computational cost. The training deep learning models requires a significant computational resources, including the powerful GPI and enable the memory, leading to high hardware and energy cost. The next disadvantage is large data requirements. So deep learning models typically vast amounts of large quality data to learn effectively and achieve optimal performance. Insufficient or low quality data can significantly hinder accuracy. The lack of interpretability may deep learning models operate as black boxes, making it challenge to understand how they arrive at specific decisions or predictions. So this lack of transparency can be a significant issue in fields requiring explainability such as healthcare or finance. The next disadvantage is the risk of overfitting. So deep learning models, especially complex ones with numerous parameters, are prone to overfitting where they perform well on training data but poorly on unseen data. The SDG stands for Sustainable Development Goals. It is also known as the Global Goals or a set of 17 interconnected goals adopted by the United States in 2015. They represent a universal call to action to end poverty, protect the planet, and ensure that all people enjoy peace and prosperity by 2030. The universal call to the action is the SDGs are intended to be implemented by all countries, both developed and developing, and are designed to address global challenges. So there are 17 goals. So these goals cover a broad range of social, economic, and environmental issues, including the poverty, hunger, health, education, gender equality, clean water, sustainable energy, economic growth, infrastructure, inequality, sustainable cities, responsible consumption, climate action, life below water, life on land, peace, justice, and partnerships. In this slide, we will discuss about the SDG2, that is zero hunger, how it is related to the artificial neural networks. And the DL as agriculture models analyze the satellite drone images to detect the crop health, pest, and soil conditions. In STG 3 is good health and well-being. So medical imaging. So DL detects the cancer from the rental diseases from X-rays, also drug discovery, and the impact of this deep learning is improves the diagnosis speed, accuracy, and affordability. Sustainable Development Goal 4 is quality education. In deep learning, the adaptive learning, that is the DL powers the personalized education platforms that adjust to a student's space. Next is the speech and the text recognition. So it helps the children with disabilities. Next, the impact of this DL is inclusive, accessible, and tailored education for all. STG number 6 is clean water and sanitation. The real models analyze the satellite images and IoT sensor data to predict water pollution, leakage, or scarcity. The impact of this is better water management in cities and rural areas through the safe drinking water access. The Sustainable Development Goal 7 is the affordable and clean energy. So, in this, the smart grids, DL forecasts the electricity demand and optimizes renewable energy resources. The solar wind power predicted the weather and the sunlight patterns for maximum energy output. The impact of this deep learning is reduces the reliance on fossil fuels. The SDG number 11 is sustainable cities and communities. So, in this, the traffic prediction and smart mobility, the DL improves the public transport, reduces the congestion. In the waste management, it is empowered by the recycling robots that sort plastics, metals, etc. The impact of this DL is cleaner, safer, and smarter cities. SDG 13 is climate action. So, in this, the climate modeling, DL predicts the extreme weather events, and the carbon footprint tracking identifies the major pollution sources in industries and transport. The impact of this DL is helps the governments and organizers adapt to climate change faster. The SDG 14 and 15 is a life below water and life on land. So, in this, the DL impacts as wildlife protection, that is, DL in camera traps the identifies the endangered species automatically. So, marine monitoring, DL models detecting the illegal fishing and predict the coral bleaching. The impact of this DL is conserves biodiversity and land on oceans. Thank you.